My name is Hannah Ezwawi, and the title of my capstone is Burning for Biodiversity, Tracking Native Plant Recovery in Hyde Park, and my supervisor is Danijela. Black oak savanna has become North America's most threatened ecosystem, with less than 3% of remnant savanna remaining in Ontario. Most of the provincially rare species and species at risk are found in this dwindling ecosystem. Oak savannas are fire-dependent ecosystems that exhibit high periods of growth post-fire, and they're characterized by black oaks, or Quercus velutina, which are the most dominant oak species and have adapted to be fire-resistant due to their deep taproots, thick bark, and ability to compartmentalize fire-induced fluids. Savannas are thought to be transitional ecosystems between tallgrass prairie and woodlands, characterized by an open canopy or less than 35% cover, which helps to support a rich herbaceous layer in the canopy below. Indigenous people, specifically the Huron-Wendat, have managed these landscapes through fire for about 11,000 years to promote growth stimulated by fire. However, in the last 100 years, fire suppression has caused woody invasive encroachment, causing savannas to transition to woodland. In the year 2000, the City of Toronto began using prescribed burns to restore and sustain native habitats, using low-intensity fires to support the growth of tallgrass prairie and savanna plant species. Historically, black oak savanna covered most of southern Ontario, with the remaining savannas only occupying 0.02% of their historical range. A large portion of the remaining black oak savanna in southern Ontario is found in Hyde Park. Hyde Park is found in the west end of Toronto and is located where former glacial Lake Iroquois was around 13,000 years ago. The glacial lake bed left a sandy, low-nutrient parent material supporting xeric and mesic soils. Low-nutrient soil results in slowed growth rate of trees, allowing for herbaceous understory to establish, increasing fire propensity and supporting the development of oak savanna. Currently, Hyde Park is a crucial green space in an urban landscape with 23 hectares devoted to tallgrass prairie, black oak savanna, and woodlands that are areas of natural and scientific interest. So to understand the current value of the oak savanna still left today, it's important to quantify the quality of the sites that remain. The Floristic Quality Index, or the FQI, is a quantitative measure to express the quality of an ecological site based on species composition. So each species is assigned a coefficient of conservatism, or a CC value, based on a quantitative index. CC values range from 0 to 10, with non-native weedy species like this dog strangling vine ranking a 0, and highly sensitive species like the sundial lupin ranking a 10. High-ranking species are found in high-quality, niche, and natural plant communities, and CC values assigned to the native plants for this study were based on the behaviors and populations observed within the context specifically of Southern Ontario, which ensures accuracy in the ranking. Once all of these CC values are assigned to all the species sampled, the FQI can be calculated for the site by averaging all of these CC values. There are other ways to calculate FQI, however, this formula minimizes the effect that sampling effort has on FQI. So the objectives for my study were to quantify the quality of frequently burned sites using the Floristic Quality Index, to assess the impact of prescribed burning and what it has on plant recovery in black oak savannas, and to evaluate woody invasive species and canopy cover to see if it has an impact on savanna quality. I followed vegetation sampling protocol, which is a robust and repeatable field-tested protocol to gather data on the burn sites. The protocol uses a circular fixed plot of 400 meters squared in area, split into 100 meters squared quadrants in the cardinal directions. Species identification and abundance was estimated in 4 vertical strata, including ground cover, shrub, subcanopy, and tree canopy. And for this study, ground cover and shrub species list in abundance, as well as canopy cover estimates were extracted. So 16 randomly sampled fixed area plots were established in black oak savanna burn sites in Hyde Park and were sampled mid-June to mid-August this year. After gathering the abundance data for the ground cover and shrub layer species, the data was analyzed and species were assigned all of the CC values and then averaged to calculate the FQI. Linear models were used to understand the relationships pertaining to burn frequency and canopy cover, and a principal component analysis was used to visualize the relationship between burn frequency and plant community composition. A permanova using Greig distance was also used to compare plant community composition as well for each plot. Now we'll talk about burn frequency. This map shows the burn frequency for prescribed burns in High Park. The spatial data was provided by the City of Toronto, with each burn being mapped as a separate polygon. These polygons were combined to create a map showing the number of burns in each plot. We can visually see that the plots with larger circles around the point indicate a higher average CC value or site quality, and that these larger circles are found in red areas or areas that have been burned more frequently. So this relationship is also reflected here in this linear regression, comparing average CC value and number of burns. We can see that the burn frequency has a significant positive effect on the average CC value of a plot, meaning that as the number of prescribed burns increases, so does the average CC value of a plot, indicating that quality of a site increases with increased prescribed burning. Burn frequency also has a significant positive effect on relative oak abundance in the shrub layer of a site. So as the number of prescribed burns increases, so does the species cover of oaks, and the oak species that were observed were black oak, red oak, bur oak, and white oak. This is also true when considering individual oak observations per site. There's a significant positive relationship between burn frequency and number of oaks per site. Now we'll look at plant community composition. So a principal component analysis shows the ground cover species in red, indicating fire-dependent species, and in blue, indicating non-fire-dependent species. So on the far right, many of the fire-dependent species are clustered, like Helianthus, Silphium, and Desmodium. So this shows that these species respond to fire frequency in a similar way, and they're all species that are high-ranking CC values. They're also heavily associated with this plot, which is an open canopy site that has been burned 3 times. This cluster shows a really strong influence on PC1. Then when we look at species that are not dependent on fire, they're shown to cluster in the bottom left corner, like Lonicera moroi and Acer negundo, and they're associated with this plot, which has not been burned, demonstrating that these species have kind of weak associations to PC1. With the relationships identified in the PCA, the ground cover abundance was separated into functional groups, including forbs, graminoids, sedges, and woody species. The Permanova results, however, indicate that the differences in functional group composition are not statistically significant, meaning that ground cover community composition did not differ between plots. Looking at canopy cover percentage was separated into 3 categorical variables. Open canopies had less than 15% cover, medium canopy had 15 to 30% cover, and closed canopies had over 30% cover. So the results show a significant negative relationship between canopy cover and woody invasive species abundance. So this means that open canopies have a significantly higher incidence of invasive woody species, while closed canopies show a significant decrease in invasive woody species encroachment. This suggests that open canopy sites, like savannas, are more susceptible to invasion. And when the categorical parameters are removed and only percent canopy cover is considered, the significant negative relationship is still observed. So to summarize the significant findings in the study, burn frequency positively affects site quality, resulting in higher CC values. So sites that have undergone more frequent prescribed burning have a higher site quality based on the floristic quality index. When considering the plot that had been burned the most, that would be 8 burns over 19 years, it also had the highest average CC value of 5.44. The burns are supporting rare savanna and prairie species, and with more low-intensity burning, it will encourage these plant communities to continue to grow from the seed bank, further perpetuating the success. This evidence strongly indicates the benefits and success of the High Park Burn Program, showing how efforts in managing this ecosystem are paying off. Burn frequency also had a significant positive effect on the relative oak abundance and presence, which is consistent with literature since oaks are fire-dependent species that grow prolifically with fire. Black oaks typically live for around 200 years, with most of the oaks in Hyde Park being established after a fire event in 1865. This means that many of the old growth oaks in Hyde Park are getting towards the end of their life expectancy, and there's an urgent need for a healthy younger population to fill the niche once the old growth oaks die. These results show promising evidence for the future of oaks in Hyde Park, since the prescribed burns are increasing oak abundance. Canopy cover was also shown to have a significant negative relationship with woody invasive species, where open canopies were shown to have higher incidence of invasive species abundance, and closed canopies had lower. Light availability is a crucial factor when considering buckthorn or Rhamnus cathartica invasion. However, limiting light availability is not really an option because that would hinder the growth of the savanna species in the understory. So the only real solution is proactive woody invasive species management, and it must be implemented post-fire to prevent propagule pressure in open canopy savanna sites from increasing. In terms of the results that did not show significance, it was found that plant community abundance did not differ across plots. So whether it was functional groups or species dependency on fire, the observed differences are not statistically significant, and there's not enough evidence to conclude that burn frequency or canopy cover affects plant community composition. It was also found that invasive species number and abundance in the ground cover layer specifically did not have a significant relationship with burn frequency. So this may suggest that burning may not be the best way to manage invasive species in the ground layer by itself. However, this could be due to limitations in the study. So it's recommended that additional plots be established in Hyde Park, especially ones that have not been included in the Hyde Park burn program since the 2000s. Currently, only 2 unburned plots were included in my study, which is insufficient for meaningful comparisons between burned and unburned sites. Expanding the sampling in unburned areas would help to clarify how burn frequency influences plant community composition. A defining characteristic of oak savanna is an open canopy with less than 35% cover. However, sites with open canopies are more susceptible to invasion. So again, intentional management of woody invasives is necessary to protect open canopy sites post-burn. And finally, the results of this study show the importance that prescribed burning has in influencing site quality, showing that the prescribed burn program in Hyde Park is actually showing success. Continuing burning will continue these positive trends in rare savanna species abundance and site quality. Here are my works cited, and I would like to thank Danijela, my supervisor, for all the support throughout this project, and Clara for the continued advice and support. I would like to thank my field team for being optimistic this summer, despite the circumstances. And of course, the 2024 MFC cohort for your companionship and support throughout the entire program. Thank you.
The internal and external supervisor to fill in evaluation sheets, and please give the sheets to me when you leave, or if you're online, you can email. So I think it's over to you, Paul.
Hannah, thank you so much for that wonderful presentation. It was so well organized and laid out. Your objectives were wonderfully clear and fine. And I just wanted to say it was really the oak abundance, finding that relationship is really wonderful. So that was kind of the initial objective of the burn program, was to increase this oak establishment throughout the park. So seeing that being clearly outlined was really exciting to find. So thank you for sharing these findings. Thank you. I guess I'm trying to see. I had a couple of questions. Nothing major, but with the non-significant findings, like, do you think that there's another way to sort of parse out the data to find something else? Like, I know often with these projects, we've got limited time, But I guess like if you could have looked at another avenue or grouping, did you kind of have any ideas of what you want to do?
Yes, of course. So, I'm aware that Hyde Park does really thorough plant surveys as well that are not following vegetation sampling protocol, but it's like species abundance. So it would be really interesting to look at that data over the past, I believe it's 25 years you guys have.
Yeah, we've done sampling from, I think, 2001 to 2016. So 16 years.
16 years, yeah. So that's, it would be really nice to dive into that data and kind of separating. I would like to see the functional group separated and as well as the fire dependent and non-fire dependent, and of course separating the invasive species. That would be interesting, and I hope to see a significant trend. I do think that the trends that were not significant in the study were just due to the limitations. And I think having multiple years of monitoring would help to kind of parse out that data and find a significant result that.
Yeah, no, for sure. I was kind of like endless opportunities really follow these data. And I know you kind of mentioned it, but a lot of what you were looking at was strictly in the Black River Savannah areas. What do you think you find potentially getting more plots in areas with communities and whatnot?
Yeah, I would love, I originally started my project thinking I was comparing specifically unburned and burned sites. However, there weren't enough unburned sites, which I mean could be pretty beneficial. I mean, that's good that there's the burning is so thorough in Hyde Park. However, if I could compare those two, like see sites that would be oak savanna that have not been burned, that would be really nice to have like that binary comparison.
Absolutely. I'm just trying to think. I think that is it for my questions, but wonderful answers and all very exciting. I think we're kind of at the beginning of some interesting research. Very confident in that part. So thank you so much for everything.
Thank you, Clara. John.
Yeah, so one of your recommendations was to continue managing the buckthorn, keep the open areas, even though we might hope that the fire would come job for you. I'm just wondering if there's, so I'm assuming your recommendation was take other measures that might be possible. I'm just wondering if there's ways that you can tweak the fire regime to improve buckthorn.
I think that for buckthorn specifically, the key thing is the light availability. So it's not the fire regime, because the fire regime will knock back some of the buckthorn. However, it's the light availability that's driving the invasion. So I don't think that buckthorn should be managed like this. I think it should be a species by species kind of take. I think that in tandem with prescribed burning, there should be another method, perhaps cut and spray with the glyphosate by applying it directly onto the cut. I think that would be a more effective way to deal with the buckthorn because you can't really get around that open canopy in the savanna sites. So prescribed burning should work to knock it down, but I think there needs to be even more of an effort specifically for
I just sort of add to that. Yeah, like within the park, we also do MFC and qualification. So definitely, I think we kind of talked about potentially including our management data as part of your study, but again, just still working and everything. But that's
even for the weedy species like dog strangling vine, I saw there was like the solarization with the tarping in the park. So there are management efforts.
I just think this is a great work. I can see that you guys enjoy your summer work, which is good. I kind of got a prize that you look around for great posters, so that's so thinking of next step. Just curious. How many plots, how many days it will be given? So it's still not that this study.
I think that doubling the plots would be kind of the minimum amount that I would want. I think that expanding into the unburned areas is definitely the next step. How many days? You know, those Savannah sites are pretty busy. A couple days, but I would be more than happy to do it. See, that's sad. Thank you. Thanks.
More questions for him? We have one at the back.
Yeah, great job. It's really cool to see it all close together. I was wondering, did you look at regen of different oak species individually at all? Like, do you know if it's mostly black oak coming back, or if it's kind of split equally between all the species that are present?
Yeah, so I split them up by individual oak species, but there wasn't enough data because they're so sparse because of the nature of savannas. So when I combined all the oak abundances, then I found a result, but there was too many zero values for them to be considered individually.
Yeah, that makes sense. Thank you.
More questions? And
Thanks, Hannah. Really great job, and really appreciated hearing and getting the data. To some extent, I'm playing a devil's advocate here, and I'm kind of I keep thinking about restoration and sort of these types of activities management. Is Savannah a transition ecosystem?
I did, yes, in the literature review, this is how they refer to it. I personally don't know if that is an accurate definition. Having a transition ecosystem makes it sound like it's not its own entity. I think that defining it as a transition ecosystem helps people to understand that you get the shade intolerant and the shade tolerant species mixing into the savanna. So it helps people to understand it. But I think savanna is its own distinct ecosystem. I don't think it's a transition.
And I was thinking of it less as a forestry classification or categorization, but as in the conditions that are there, because if you look at the sites in Toronto, a lot of them are down by the original water, like sandier sort of areas. And so I would think over geological and climatic time that things are transitioning, which could of course move the vegetative communities. So I was thinking of it in a bigger scale. So to me, it kind of then, when we talk about Indigenous people, I often ask, did they create these savannas, or do they just maintain and sustain them because they found them and make them work for them?
Yeah, that's a good question. The savannas specifically in Hyde Park are edaphically derived, so they're from the soil and the parent material. So I think when referring to it as a transition ecosystem, it means spatially. So if we're transitioning from prairie to woodland, then that would make sense. But these Indigenous people would burn to kind of bring out the germination and growth stimulated by fire. So it helps to perpetuate savanna. However, the savanna would be there.
Yeah, I'm just thinking it's the transition that I'm thinking is temporal, not spatial, although it has implications spatially. But I guess it comes back to my question, and I've often asked it to myself, how much should we invest in maintaining, sustaining, or trying to restore an ecosystem that wants to move somewhere else? And that may be because of us or not. I think with the courtyard over in Earth Sciences, it was designed as a boreal courtyard, and yet it wants to transition to down here. So how much do we invest in it?
Yes, I've been asked this multiple times. I think that if it was transitioning into woodland anyways, then I believe that you should kind of listen to what the land wants to do. However, we are actively suppressing fire. So that's why the savanna is disappearing. So I think that there needs to be a sort of balance in between. Yeah.
Brilliant.
Thanks.
are there any other questions? Thank you. Oh, one more. Hang on.
Thanks for the presentation, it was really great. I was just wondering if you know like any other studies comparing like burning to like community movement programs or like other management with regard to like an ecosystem like the Black Oak Savannah, which is fire dependent, and how that compares on the AQI index.
Would that be like, are you talking specifically? Sorry, I don't think I understood the question.
Like comparing, like, let's say like a community invasive removal project
Oh, yeah.
to something like burning for biodiversity.
Yeah, I think that they can be used in tandem. I know that the park I worked at in Windsor that had Black Oak Savannah, there were community removal. I think that it can help to sustain and supplement Savannah. I think that burning alone won't save our savannas, you know. But transplanting, community transplanting events or invasive species removal can help to kind of help the savanna. Yeah. Thanks.
Okay, thank you, Savannah Hannah.